Alright, so what I'm going to do here is try to simplify how use after free works. And basically what use after free is it's a dynamic memory vulnerability. So when you use things like malloc or calloc that allocate space on the heap, you get a pointer back to where that memory is on the heap. And when you deallocate that memory, the pointer is still technically valid. And the issue with this is that when you reallocate that memory that you deallocated, you generally create another pointer, but the previous pointer that was originally made for that location in the heap is still valid. So you can access that memory that you deallocated originally with the same pointer, even though this space in the heap is now for new data. So this is kind of a basic program to visualize how this works in heap memory. So first what we do is we call malloc to allocate 20 bytes on the heap, and we save the address to this malloc memory into pass. So let's just say that this is like 20 bytes of allocated memory. Next, we ask the user for their password, and then we store that character string or that character byte array into the allocated memory. So let's just say that we store like x, just a bunch of x's is their password, and it takes up those 19 bytes plus the null terminator. Now let's just say that we do something with this password, we process it, we get past this, and then we free this location memory. Now let's just say that, just imagine that these 4 x's are those 20 bytes of data. Now, and also, let's clarify this. This square represents 20 bytes of memory on the heap. And we can say that this pass pointer points to this square. Now, there can be other squares if you allocate even more on the heap, but this pass points to this specific 20 bytes of memory. Now, let's just say that we free this memory. Alright, let's go to the eraser. Now the way when you do free, all that's doing is just saying that, okay, this data on the heap isn't valid anymore. So you're giving it the heap, you're giving the system permission to overwrite it on the heap, but that data is still there. All you're doing is just kind of erasing its validity as valid data. Now let's say that after you do this, you call on malloc again and allocate another 20 bytes. Well, all you're doing basically is just setting up that square that was there before. That data that you wrote there was still there. Technically, if you wanted, you could access this data, assuming it hasn't been overridden. But what use after free does is it assumes that this pointer of this pass isn't important. So like it's kind of like a junk. It's not really important. But we're also, use after free also assumes that this new allocated memory is this new pointer to allocated memory test is going to store something very important, something like, or it doesn't really even have to be important, depending on the implementation of PT memory. It could store like literal very important data like passwords, information about the system. But what some implementations of PT memory do, instead of just leaving the data there, it'll overwrite the data with metadata about the heap. And this metadata is very important for how the heap functions. You can get into a whole like tree of different heap exploitations just based around altering metadata. But we're just going to assume that this new use of test, this new malloc that sends the address to test overwrites this with like very important red data. So we can just say that this red data is important. And we can also say that these 20 bytes in the heap are also pointed to by test now. Now the issue is that this pass pointer is still valid. So we could, like let's say we store an SSN here, a social security number here. We can just use the pointer that we had previously to print out what's there right now. The issue is that when you call something like free, you're just shrinking the size of the heap itself. You're not like going somewhere else in the heap, like starting it here or starting it up here. You're starting because the heap grows and shrinks as you allocate and deallocate. So like think of it like I allocated here, but and then as time passes, I deallocated that memory, and then I allocated again. But if I do the exact same thing, these are the exact same like addresses in the heap. So that's kind of the issue of use after free. The big issue is that pointers are still valid even if you deallocated the memory that they pointed to. If you allocate new memory and put new data there where the original pointer pointed to, you can access it with that obsolete pointer. Now, if this explanation was helpful, then you're welcome, and thank you for watching this video.